We have an eminent speaker with us today, Dr. Vinod Gaikwad. I take this opportunity to introduce him to you. Dr. Vinod Gaikwad is currently working as an associate professor at Pune College of Pharmacy, Pune. He has total of 12 years of experience in research and academics at undergraduate and postgraduate level. He has completed his PhD on computer-aided formulation development in the year 2014. He has to his credit total of 2 patents, 28 international publications in journals of repute with a cumulative impact factor of 52, out of which 15 he has published as first author. He also has to his credit 2 book chapters and 10 papers presented as various national and international conferences. As far as the research area is concerned and the research publication and contribution in this area is concerned, he to his credit total citations of 207 and has an H index of 6. His key research areas include computer-aided formulation development, QBD, design of experiment, novel drug delivery systems, particle engineering, and solubility enhancement techniques. Dr. Gaikwad has guided 26 students at MPharm level and 1 PhD student pursuing her PhD. He is recipient of AICT, JRF, and UGC research grants. He has completed several consultancy projects and delivered talks as invited speakers at several conferences and workshops. His today's topic of talk is computer-aided formulation development and biopharmaceutical characterization. We welcome you, sir, on behalf of Bharati Vidyapeeth and request you to continue with your talk.
Thank you, ma'am, for a nice introduction. So that is a post-lunch session. I welcome you all for this post-lunch session. So I will just start with my presentation.
Yes,
let me share the screen.
Yes, sir.
Okay, is this screen visible?
Yes, sir, visible.
Okay, thank you. Okay, my today's talk is on that computational modeling in formulation development and biopharmaceutical characterization. So this is also called as QSPR modeling in formulation development. So as we all know that polymeric excipients are required for achieving the suitable type of drug release. So for getting or achieving that kind of drug release, a suitable polymer system is required to control either control that dissolution or to decide the mechanism and rate of extent of drug release, or to achieve site specific drug delivery, or to reduce that dose or dosing frequency, or to increase the drug in vivo efficacy or efficiency and patient acceptance. So for achieving all these parameters, we need to have suitable polymer system, and selecting that suitable polymer system is of critical importance, or it is critical step in formulation development. So if we want to overcome this selecting critical step of selecting that polymers or excipients that are achieving your desired release, you need to have a comprehensive knowledge of that polymeric physiochemical properties, or we can say the molecular properties of that polymer. Then only you will get a formulation with desired properties. So you may end up with a formulation with all that desired properties. That may be it may be pre-compression or post-compression, including that dissolution profile. So I will just briefly give the introduction or basics of that computational modeling. So previously we have already studied in our UG course or BPharm course that what is SAR. So it is just a structural activity relationship. So in that we have already studied that removing that group, any one group reduces the activity, introduction of any of the group increases its polarity or reduces its activity or increases activity. So that kind of relationship between the structure and activity of that compound is highly important. So studying, understanding, and interpreting that kind of interaction between, relationship between that structure and activities of prime importance. So that extension of that SAR is QSAR, and that you are expecting or predicting quantitatively the relationship between structure and activity. What is the importance of that kind of quantitative? I will just give one example, short example, that we all know that increasing the number of carbons in that any of the compound or that methane increases the melting point. So increasing carbon atom increases the melting point, and that relative, or that you can say, that is the relationship between the number of carbon atoms and melting point. But how much number of carbon atom? For say example, 4 carbon atoms give 40 degrees Celsius, 5 carbon atoms give 50 degrees Celsius. So that is the quantitative approach between that number of carbon atoms and melting point. So number of carbon atoms are related to the melting point, means they are, as they are increasing from 456, melting point is also increasing from 40, 50, 60. So that you are quantitatively relating the structure with its melting point or that activity or that property. And that approach was further proceeded with some extension to other types of areas also. So that was extended as QSPR. And as you all of you know that QSAR, it is structure activity relationship. QSPR is structure property relationship. So Fraser and Crum-Brown initially in 1868 this introduced this approach, very first introduced this approach, and related chemical structure with physiological activity. So you can relate any of these properties with that structure, either maybe reactivity, permeability, electrochemistry, chromatography, toxicity, or biodegradability. So it is just a common functional relationship between the activity and the physiochemical or structural properties. So that physiochemical or structural property, if anyone is able to identify or estimate that physiochemical and structural properties, then that person or that individual can also predict the activity for that compound, activity, or we can say that property. So why there is need of computational modeling? So as you all of you know that traditional F&D approach, it is totally based upon the trial and error approach. So it is also time consuming and uneconomical. So if you want to develop any of the drug delivery system with a desired approach or with desired properties, it consumes time and it is very challenging. So current scenario of that pharmaceutical industry is related to the development and not the discovery of NC by modification of properties. So each and every Indian pharma industry is totally engaged in development of existing NCs or new chemical entities. So for that purpose, in developing that new chemical entities, it is not necessary to analyze each and every structure. So you need not to modify and analyze each and every structure, because that will be again time consuming or costly. So instead you can use prediction methodology like computational modeling. That prediction methodology can be used to predict that structural properties. So in that computational approach is used, and it will or after application of that computational approach, you will get one powerful predictive model which will be able to understand the relationship between the system components and the structural parameters or requirements that are required by model. So it will quantitatively influence the structural properties on the response, or what will be the quantitative influence of that structure on the response or our properties under investigation. So this will no doubt encourage the fast growing resources, computational resources, as well as encourage that formulators by implementing that computational approach in formulation and development. And no doubt this will also accelerate the early stage formulation development work. So there are numerous advantages. You can theoretically predict the property based upon the structure. You can select the most suitable composition, formulation composition with desired characteristics. You can avoid multiple trials or repetitive trials, which assist formulators in rapid early stage formulation development work. Then you can reduce the duplication of work, that by creating the systemic database, you can also reduce the duplication of work. So that creating systemic database is again another challenging task. So again, no real time or actual formulation of that drug delivery system is required. We will see how this will work, and no doubt all these advantages will finally turn into saving of time, material, and processing cost of that is incurred on formulation development. So, but there are some limitations, that a trial and error approach cannot be completely eliminated. Say for example, in traditional F&D approach, you are supposed to take, or you are taking 100 of batches for finalizing one formulation composition, or you are ending up with one formulation composition, and that one formulation composition out of 100 will work. But what if I suggest that if you can, without formulating hundreds of batches, you can just end up with 10 of the batches by this computational modeling approach. You have to just formulate near about 10 batches, and you can end up with the formula, the same formula which will you are supposed to, or you are interesting, same as like from 100 of batches. So that reduction is possible, but that trial and error approach cannot be completely eliminated. It will just reduce the number of attempts or number of trials in for example, formulation development. Okay, but that some properties cannot also be predicted or measured accurately, like drug transport, or that drug receptor interaction, or pharmacodynamics cannot be accurately measured. You can measure it, but that relationship will not be that much accurate. So there will be again there is in industry formulators, there is some lack of confidence in silico predictions, because of which it is not adequately exploited by industry people. So this computer aided formulation development totally is based upon the working as intelligent. So this picture itself depicts that you need to work intelligent or in smart way, and not to work hard. So what will be if you are having one formulation composition in your hand or on your paper, that this is drug 1, this is polymer 1, polymer 2, polymer 3, and this is on paper only, yet not you have not formulated that formulation also, and this is on paper, formula is on paper only, and you are just saying that by seeing that formula only, and by applying that computational modeling approach, you are saying that this formula will give you this much drug content, this much drug release, or this much disintegration time. All these properties you can just predict by analyzing that formula, and by fitting it into that computational model. So this is also possible, or vice versa is also possible. What if say you are having target value of drug content, target value of drug release, and target value of that disintegration time, and if anyone comes to you with that these are my targeted values, say drug content 90%, drug release more than 12 hours, and disintegration time for more than 15 minutes. So for that targeted values, what if you can predict the composition within no time, compared to that for actually formulating dosage form, and testing its all these testing that dosage form for all these properties. So within, for say example, say 5 minutes, you are just predicting the composition of formulation by analyzing the target properties, or by saying that formulation composition, you are just predicting the targeted properties. So vice versa. So this is actual smart working or intelligent working, and likewise we have explored this computational modeling approach or AI approach in formulation development. So for that purpose, for development of computational model, one needs to have proper knowledge of that structure. So you will going to study that structure, then based upon that structure, which properties of that structure will have proper or significant influence on your study of that property or property of interest, formulation property of interest. For that purpose, you need to have or need to select one proper correlation method. But before you start, you need to learn how to finish it, because you will just wonder or you will just that end up with that this is messy thing, that computational modeling is of no use, or it will not lead to any of the prediction methodology. So development of computational model, in that first one you are going to select the structure and study that structure and calculate the molecular descriptors. So as you all of you know that 1D, 2D and 3D descriptors are there. So depending upon your requirement you can proceed. Then these are different types of descriptors. So depending upon the applicability of your formulation, you can select either of these descriptors. So either maybe it may be geometrical, constitutional, electrostatic, hydrophobic, hydrophilic, elemental count, distance based, quantum chemical. So that is again up to you which type of descriptors you are supposed to select. Then after selecting that descriptor, you need to have one proper correlation method. So this is one of the critical step, as I said earlier, because the if you are not going to select the proper correlation method, it will not give a relation or correlation between your input and output, proper correlation between your input and output, and you may end up with that key this model is not that much applicable or inversely applicable to your data set or selected data set. So for that purpose, you need to select a multivariate statistical analysis technique. So there are a number of techniques, out of which you need to again select depending upon the data set. You need to select either of these techniques, but most popularly these first four are generally preferred. MLR, that is multiple linear, PLS, partial least square, multiple line principal component analysis, and artificial neural network. So out of which that MLR is very much popular, and it will give this kind of regression, polynomial regression equation. I think all of you are aware of this equation. This is our response. All these are regression coefficient, and this is our independent variables. So likewise, you can get that regression equation by applying that correlation method or statistical method. So at the end, you need to validate your computational model. So quality or success of any of the computational model totally depends upon the accuracy. First, the most important step is you need to select most accurate data as an input to that method. Then for that, you need to select appropriate descriptors, and again select proper statistical method, and finally you need to properly validate that model. So that validation is again reliability on the variables of the variables on the response, and it is not, no doubt, it is going to give the robustness, prediction, performances, and applicability domain of models. So after validation or during validation, some of the models show high R square, but their predictability quotient or predictability coefficient will be low. So you need to identify such kind of models. So here R square, you can see that what you are seeing is not much important, but what is success is much important. Here you may see R square around 6.6.7, but it is going to accurately predict the model or predict the response depending upon your data set. So that's why success, it's not always what you see. So if you end up with R square that is 0.999 and you are saying that my model is best or computational model is best, and you are just completing the things, wind up with that model saying R square is 0.999, but it is not always like that. Ki success, it's not always what you see. So validation, either you finish it up with either of these four techniques or four methods. In that you can use cross validation, external validation, blind or true external validation, or data randomization, or Y scrambling. So depending upon again requirement of your data set and your final target, you need to select proper validation method. So, but some validation methods are again problematic. Some of they may overestimate the response. As I said earlier, R square may be 0.999, but your model will not be that much predictive for selected properties. So there is demand to equally develop one novel validation parameters that will accurately estimate the response. So after or at the step of validation, if your validation fails, if your model fails for validation or validating that predicted response, then you may end up with that this second fellow. So you may end up with that this model is totally useless. It is of not much. It is not of much use to me, and I will just give up with this model. So I have just replaced that word with QSPR or computational model. So most of the QSPR failures are those who don't know how close they were to success when they gave up. So you need to finish it before starting. You need to know how to finish it. Again, this picture also present that how much you are closer, but due to improper selection of the data, selection of the improper sets or molecules in particular data, and without proper validation, you are just ending or giving up without a final model. So these are the steps whatever we have discussed up to this point. So you need to suppose predict one of the formulation property, then you need to generate a computational model. That computational model will be generated based upon the structural descriptor, and it will be allowed to predict the response. So if that response prediction is accurate, then you can say that model is validated. So if that predictions are good, then you can improve. Sorry, if they are good, then you can stop with that model development. If they are not good, then you can just keep that cycle repeating to improve that computational model. So there are again number of software programs, different software programs which offer number of assessment of number of parameters. Again, number of statistical programs are there. So you can select depending upon the availability of these softwares. So after developing or during development of that computational model, you need to select one of the biopharmaceutical property, or you want to develop your model or computational model for any of that physiochemical, biological or biopharmaceutical properties. So you can develop model depending upon the requirement, your requirement or research requirement. You can select either of these properties. Means this property list is not limited to this one, but because of that size constraint, I have just included only that representative property. So you can select any kind of property. If you are assuming that keyword structure can be related to your property, you can select that property for model development. But if you see here, there are some of the properties from pharmaceutics department, some of these related to the pharmacognosy, ecology or chemistry. So there must be coordination, or coordination must exist between that people. So if you observe that from first slide up to this slide, okay, there is involvement of that organic chemist, or that the person who is having hand on that modeling approach, or chemistry person, pharmaceutics person. If you want to develop model for in vivo studies, then pharmacologist, or if you want to develop model for phytoconstituent, then pharmacognosy person. So there must be a coordination between all of these involved expert. So coordination must exist, sorry, or there is no organization, there will be only experience. So we are not supposed to end up with only experience, but you should have a proper coordination between other colleagues, and colleagues means that which are involved in your research area, and that coordination will definitely end up with that proper or fruitful output with interdisciplinary research.
Hello,
So
hello,
Hello.
Vinod.
hello.
Hello, Vinod. Sorry to
Yes.
disturb. I
uh,
think screen sharing is some other participant is sharing the screen. Please check.
one
Your
one
screen
minute.
is not visible. You share it again, Vinod.
Okay, 1 minute.
Stop and share it again.
Yes, now is it visible?
Just a minute.
Yeah. Case study.
Yes, case study.
Yeah, visible.
Okay. So I'm not exactly means catching that key where at what point I have left, but okay,
Just
that
now,
by
just now.
just now. Okay. So what I'm saying that coordination must exist between all these people, and there will be only experience without any fruitful output. So whatever we have discussed is compiled in that very first publication. Uh, that polymers influencing transportability profile of drug. You can download it from internet as well. And that second publication means review article is on computational QSPR approach in formulation development. You can also get this paper online. So we will directly start with that different case studies. So this is the first paper we have research paper we have published by selecting ibuprofen as a drug representing acidic family or acidic class. So here we have developed a computational model for predicting the release and transportability from ibuprofen. So in that we have prepared first we have selected different polymers for different targeted profile means for immediate release, moderate release and extended release, and that formula was prepared and that tablets were prepared with uniform weight of 600 plus minus 5 mg, and ibuprofen is the active included in that. So with use of that softwares we have calculated number of descriptors for that polymers, and that descriptor list is given here. So I have just shown here that representative list of descriptors. So that list is too long, so cannot be means it is not of that much sense to include each and every descriptor on slide presentation. So after correlating that with that tablet properties, means we have investigated hardness, friability, T 90% and percent T 60 minute, means this is release and this is transportability. So we are here are much interested towards the release and transportability. So we have correlated that property with that formulation characteristics, means release and transportability. So like regression equation, we have obtained here number of parameters. I think all of you are aware of these parameters. What is R square, Q square, that is robustness, F test, standard error, intercept. So that is these are the values or constants in that regression equation representing the predictability of that regression equation, and all these are the our independent variables against which we are getting these values. So these values are representative of that particular structure. So this is the model, computational model, as like regression equation we have obtained for that T 90% or the drug release at time required for drug release of 90% of initial amount of drug release. So if you compare here, that H acceptor count is having positive effect. Positive effect means what? It is going to increase as H acceptor concentration increases, T90 also increases. T90 increases means drug or there will be a slow drug release. So drug release will be at slower rate. So slow drug release indicated by the H acceptor count or related by H acceptor count is representative of initial slow drug release. So H bonding of that polymeric high content around that drug gives poor availability to the media, and because of which that drug cannot leave that polymer. So during that initial time high concentration of polymer is around the drug, and because of which media will not be in intimate contact with that drug, because of which that drug will be at drug release will be at slower rate. So similarly that H donor count of that polymer has impacted positively, but comparatively compared to H acceptor count the effect is lower. So this indicates that with time that dissolution media is weighting of that tablet occurs with time by that dissolution media, and that H hydrogen count or hydrogen bonding of that polymer drug get dissociated, and that dissolution media is now in intimate contact with drug, and similarly or slowly increasing the drug release. This hydrophobic area is again representative of the hydrophobic character, and this XA most hydrophobic philic distance is also measurement of the non-polarity or polar characteristics of that molecule. So this distance, higher the distance, the greater will be the non-polarity. So this non-polarity and hydrophobic character both shows positive effect. Means what? Okay, as hydrophobicity or non-polarity increases, it increases the time for wetting of that tablet, and because of which T90 also increases, means there will be slow drug release. And that last descriptor, that is KIV5, it is related to the atomic valence connectivity index, and it is one of the measurement of the steric property. It gives estimation of the branching within polymer, its size and flexibility. So as you all of you know that branching increases the entrapment or swelling, and again that will be more feasible to increase the drug release. So this negative sign of that KIV5 indicates that key this T90 is increased and drug release will be at faster rate. So fast drug release you can observe with increase in KIV5 character within that polymer. Similarly, for transportability, you can predict which properties of that polymer are going to affect in that way. So Chi-5 chain, again, it is 5-membered ring. So it is again measurement of the hydrophobic philic balance of the polymer. So this will also increase the positive sign indicates that the transportability increases with Chi-5 chain. Again, with H donor count, transportability increases. So these two parameters or two variables are responsible for increased transport. But if you find here that Balaban index J, kappa 3, both these are related to the shape indices of that polymer. So if there is irregularity in shape, so that will again increase the interaction with drug, means there will be a strong physical bonding between the drug and polymer, and that will not much give or reduce the free drug content for transport available for transport. So that's why their negative effect is there. So negative effect indicates in presence of these characters, drug transport get reduced. And the same cases with again hydrophobic philic distance. So non-polarity, again it is one of the indicative of non-polarity, and because of that it will reduce the drug transport because it increases interaction with the hydrophobic drug. That is, in this case, our ibuprofen is the drug. It is hydrophobic, means with poor water solubility. So non-polar characters of that polymer interact strongly with that drug, ibuprofen, hydrophobic drug, and it will reduce the transportability of that drug. So likewise, we have also predicted. So if you can see here, means we have compared actual and predicted values. So if you can see here, if you are able to see, hello, can you see these values?
Yes, sir, the graph is visible.
Okay, I will just,
Values not clearly visible.
okay, now.
Yeah, visible now.
Okay, if you find the difference, means if you compare that this is actual and predicted values, so the actual one is 4 and predicted one is 5, then here 1921 or 811. So this difference is you can easily observe between the actual and predicted value, which indicates that your model is means model is having good predictability. So this is just comparison between the actual and predicted values. So if your model is too accurate, or if you want to develop a model with universal applicability, then you need to give a correct data set. So what we end up with that research is, if you are having or suppose if you select any of the polymer which is having H acceptor count within this region, H donor count within this region, SA hydrophobic character within this region, means these two parameters representing hydrophobicity within this region, that is log P within this region, you will get hardness of this value, means for immediate release formulation. Okay, we will directly move towards that in vitro drug release. So that model we have already seen. So if you are selecting any of the polymer which is having characters of H acceptor count in this region, H donor count within this region, then SA hydrophobic area within this region, and XA most hydrophobic philic distance within this region, and Chivi character within this region, then you will just get that formulation which will give 90% of drug release within 7 minutes, near about 7 minutes. So that is model for immediate release. Then for moderate release, if you are selecting polymer which represent or fits within all these requirements or criteria for that property, you will end up with this T90%, means near about 380 minutes. And if you want to develop extended formulation, you need to select polymer with these characters, and these characters are the polymer which is fulfilling all the characters at once will give the release of 560 minutes. So likewise for in vitro drug transport, if you want to develop this immediate, moderate and extended release for targeted transport, you need to select polymer of that individual, means fulfilling the criteria for that individual property. So you can directly predict the drug release and transportability from that unformulated dosage form. So predicting formulation composition of that untested polymer with same physiochemical properties, those which you have already assessed, is possible. Or you can also develop the novel dosage form or optimize that existing one, which will save a lot of repetitive work, time, material, energy, and cost of that formulation development. So likewise, we have developed for basic drugs also and neutral drugs also. I will just give another more two examples which we have explored. So in previous example, we have selected only one polymer, or considered that key there is presence of only one polymer in that formulation. But that is practically not it is possible. So that as all of you know that the formulation composition contains number of excipients or number of polymers within that. So what is the effect of that polymers? Or hello, is that screen visible?
No, have you started sharing your desktop?
No. Someone
No.
is interrupting in between.
Um, Not visible, sir.
Now that research article 6.
Yeah, right. Visible now.
Okay.
Carbohydrate polymers, right?
Yes. So
Yes.
so up till now we have considered that only one polymer present in that formulation, but practically it is not possible, as you all of you know that any of the formulation contains number of the polymers in same composition or same formula. So the same approach was addressed here. So we have developed a model for prediction of that formulation properties. So accordingly, we have prepared total 17 batches, and we have explored that uh, approach for predicting the property or predicting that release for formulation containing number of the excipients. So likewise, we have analyzed that after development of that formulation, we have tested it for in vitro drug release, and further we have developed a computational model with calculation of that descriptor. So this is our model, and this model suggests that key that H acceptor count is having positive effect. You can see here H acceptor count is having positive effect. S log P is having positive effect, and chi V5 is again having positive effect. So all these are having positive effect. That means what? T90 is increasing with increasing H acceptor count, S log P, and chi V5 count. So all these three properties increases T 90%. That is increasing the time required for 90% of drug release. That means drug release will be at slower rate. So that slower rate of drug release characterized by all these properties. So if any of the polymer is having a good acceptor count or S log P good, no doubt this is the hydrophobicity, and Chi-V5 that is again going to influence the swelling pattern and disintegration, lower disintegration of that tablet. So all these three parameters for that any single structure will increase that T90 or reduce the drug release at slower rate. So if you find here that we have found R square as 0.96 and that robustness of that model is 0.93. So this model is too much, means it is considerably good predictable, and its predictability we have tested with some external data set. So we here up till now we have used only internal validation approach, but in this work we have used a true external validation approach. So here we have prepared one enalaprilate tablet formulation, and for that we allowed to predict that property T90. Here you can see that formulation composition. This is last batches of that you can say validation batch. So this is the validation batch, and the predicted value is 67 minutes, while that experimental is 61 minutes. So that minute difference between the predicted and experimental batches or experimental values, you can just assume the predictability of that model. So only 6 minute difference is there. So that means what? Without preparing now, henceforth, without preparing that batch or that formulation or that tablet, you can directly predict the release. So that we have already discussed. What if you can directly predict the release without preparing that tablet by just seeing that formula? If you are just seeing that formula, and by seeing that formula only you are predicting the release, that is more than means miracle, I think. So again, the same work we have explored for some nano drug delivery. So nowadays means since last decade we have coming across with this nanotechnology. So we have explored this concept in nanotechnology also. So that liposomes, as you all of you know, that liposomes are having lipid core and that biphases of aqueous core, so or watery core, and that center part is liquid core. So in that bilayer or entrapment of drug within that bilayer is too much tedious. So if you want, or what if you can predict that drug entrapment within that bilayer without actually preparing the liposomes? जस्ट इमेजिन आपको अभी लिपोसोम बनाना है, तो आपको पहले वो पॉलीमर या जो भी है आपको कोलेस्ट्रॉल लिपिड सिलेक्ट करने पड़ेंगे, ड्रग उसमें डाल के फिर आपको मिक्सिंग, बाद में वैक्यूम इवेपोरेटर, बाद में रिहाइड्रेशन, और बाद में वो ड्राइंग या जो भी है आपका फ्रीज ड्राइंग, वो सब के लिए एटलीस्ट 2 days तो लगेंगे. बट by using our model you can just predict the end. Okay, आपको वो न्यूज़ोम सॉरी लिपोसोम्स भी मिले 2 दिन बाद, फिर आपको इवेल्युएट करना है उसका ड्रग कंटेंट कितना है, फिर आपको पता चलेगा कि नहीं इसका तो 40% ही आया है, फिर आप रिपीट करोगे दूसरा फॉर्मुलेशन, फिर 3-4 दिन, फिर 3-4 दिन, ऐसे करके आप कब खत्म करोगे? मींस इट विल टेक मोर देन 8-10 days to at least reach up to the 70-80% of drug release, which is not actually practically possible. But with use of that model which we have developed, you can directly predict the entrapment of hydrophilic drug for that bilayer, or hydrophilic drug entrapment within that bilayer. So you just need to input or give the input of values in that our model, and you can directly predict the entrapment for hydrophilic drug within that liposome bilayer. So this task will take not more than 2 minutes. So within 2 minutes, you will have the entrapment predicted for your liposome. So that approach we have explored already, and that is again for that liposomes we have already developed for targeted drug delivery. So that liposomes, first we have identified which variable is having a significant impact over that entrapment. For that phosphatidylcholine or phospholipid and cholesterol we have selected as independent variable, and after वो जो design expert है 3:2 type of design we have applied, and after investigating that, we identified that key phospholipid is having considerable impact on that formulation. So that if you find that before batch it is having 74 entrapment efficiency, and the most significant impact is of that X1, no doubt it is phospholipid. So that phospholipid, we found that the phospholipid is controlling entrapment at the or towards the dominant side or major side. Further, we have used that PAT technique, also process analytical techniques, to identify which are the process variables which affect significantly the formulation of that liposomes. So similarly, we have studied loading time, lipid temperature, and stirring speed, and end up with some common factors or the improved or significant factors which affect or which gives highest entrapment efficiency. So बाकी के variable you can keep constant by applying this PAT kind of approach. तो अभी loading time इतना constant रखा है, lipid temperature भी इतना रखा है, stirring speed 100 को रखा, drug injection method ethanol रखी, 10 ml you have to inject within or with 2 ml per minute of rate, and then you will get 76% of drug entrapment. So further, that in vitro drug release from that liposomes were further lyophilized, and in vitro drug release was evaluated. So lyophilized and aqueous liposomes showed near about 76% drug release and 98% MTS release in 180%. So that again explored for ex vivo drug diffusion study. So this is the graph of that percent drug diffusion using that bronchial smooth muscle. What is the main part is the development of that computational model. So accordingly, we have calculated the discrete task for that selected structure, and we have applied here principal component analysis as a method for selecting that suitable discrete task. So that green dots you can see here, these are the suitable discrete tasks which are having significant impact of on that entrapment efficiency of that liposomes. And then we have performed PLS regression analysis for estimating various regression parameters for that model. So after analyzing this model we have finally got, and this model was further explored for validation also. So it was tested tremendously in for number of lipids. So here you can see that that TPSA, hydrophilic area, and that POE, that is van der Waals surface area, that both these or all these three parameters are hydrophilic parameters, and that will give the more hydrophilic space for that hydrophilic drug entrapment within liposomal bilayer. But that log P, if you can see here, log P value is again representative, or the low log P value is indicative that the drug is more soluble in aqueous core, and it will now get more entrapped in inside that liposome with reduced free drug content. So that model which was developed here was further modified, validated. तो हमने क्या किया, अभी एक नया phospholipid लिया, and after selecting that new phospholipid, we have allowed that model to predict that entrapment efficiency, and which was subsequently validated by experimental testing. You can see the difference, that is the predicted was 64 and experimental was 71. Again, that lipid was replaced with second lipid. This lipid we have selected, then third lipid के साथ भी prepare किया, fourth and fifth lipid. So likewise, you can test number of lipids for their predictive ability. तो अभी यहाँ पे if you compare that the difference, or if you observe the difference between that predicted and observed values or experimental values, you can see that कि you need not to actually prepare that formulation. You can just predict that entrapment efficiency for selected lipid. तो अभी आपको यहाँ पे कुछ लिपोसोम बनाना नहीं है, कुछ भी नहीं. You just select virtually any kind of lipid, and it will give the predict, or it will predict entrapment efficiency for your selected phospholipid. So this kind of technique is also useful in that screening design, as we see in that QVD approach. So screening design, as you all of you know, that key out of that hundreds of molecules or hundreds of batches, you want to select only 4 5 batches with most significant influence or with most significant or desired property. So in that case, or for screening, you can just go on predicting the entrapment for suppose for say example अभी यहाँ पे 100 lipids है, so you just go on predicting entrapment efficiency for that hundreds of lipids, and you just select those only which are having highest entrapment. For say example here, this is the phospholipid which is having higher, and that DSP 84 is having again highest entrapment. So accordingly, you need to select only these two lipids and only experimentally prepared neosomes of these two lipids only. Or practically you can observe and just end up with कि हाँ no, that DSP is actually having good entrapment. तो आपको एक्सपेरिमेंटल पार्ट कुछ नहीं करना है, आपके पास 100 या thousands ऑफ लिपिड भी है, जैसे आप कौन सा भी एक्सपेरिमेंट स्टार्ट करते हो सपोज लिपोसोम या न्यूमोसोम का, तो उसमें आपको पता नहीं रहता कि which lipid or which cholesterol or non-ionic surfactant will give maximum entrapment for my for say example liposome or neosome. So you may just end up with that data screening. So same approach we have again explored for one another approach, that HPMC अभी अब हमारे पास that we are having one polymer, but that polymer may exist in number of grades. So which grade is more suitable for you? So that grade selection is also again modeled. We have modeled that grade selection of any of the polymer. So we have means end up I will just end up with this with that our observation. So we have end up this with we have performed study on that HPMC, and we have observed that कि आपके पास सपोज K series polymer है, it may be K4M, K6 sorry 35M or K100M, that you cannot replace with any of that other series of polymers. For say example K25pH, that K25pH we have selected here, and these 4 polymers or grade of polymers we have selected for testing. So that any K and M series you can predict from by using this model. So if you want to predict release for any other grade which holds K as initial letter and M as the ending letter, तो बीच में कौन सा भी रहे, कौन सा भी नया पॉलीमर आए मार्केट में HPMC के say for example 70M 60M, so you can directly predict the release out of that polymer. But आपको same model you cannot explore for that other type of grids or types of that different types of that same grid. So you can again legally protect your invention. That computational model you can predict, but descriptor and models you can predict as invention, means predicting the method for deciding the affinity of ligand to descriptor or release from structure you can predict. So just remember these 5 key points. So that QSAR, QSPR, or that computational modeling can be turned into the source of intellectual property. There is ever increasing importance, a way to benefit from it, get a benefit from it. Then means allowing for developing any kind of computational model for universal applicability, you need to have good data set, and that models which may be developed must be robust and focused, and there must be a robust central killer descriptor which will be a good competitor between or which will be the good significant point for you between you and your competitor. So no doubt I will just end up with summarizing this my PowerPoint, that you can formulate your drug delivery system by using that computational modeling approach, which is one of the most efficient and cost effective approach. So you can predict the property based upon the given formula, or you can predict the formula based upon the given property without actually formulating that dosage form. So any kind of polymer from same class you can select for prediction. So you can just end up with developing that formulation without expensive and time consuming trial. And no doubt this will save repetitive work, time and material expenses. So no doubt जैसे number of batches कम होंगे, that will be again have some impact on final cost of the formulation, which is or marketed tablet or any kind of formulation. which is developed through number of trial and errors or through vigorous input. That may be in terms of that money or energy or anyhow. So no doubt, I must say that I'm not claiming, but I'm just expecting that in near future, this computational modeling would be integral part and part of that FND work, formulation development work, and no doubt it will accelerate the early formulation development work. All this the total work which we have seen here is part of my PhD research, and my the humble gratitude to my guide, that is MA Manish Bhatia sir, who is a coordinator of same conference also. So because of whom I got this opportunity to explore this area, work on this area, and gain whatever knowledge what I have gained up to this point in this area. So thank you, and I am very much thankful to Principal Dr. H. N. More sir, Coordinator Dr. Bhatia sir, and Bhatia madam, and all other colleagues for giving me opportunity to present my uh, work and give little input for that computational modeling. Thank you.
Yeah, thank you so much, Gaikwad sir.
Yes.
Now I request all the participants, if you have any queries, any questions, anything that you want to discuss with our today's presenter and resource person, so you can raise your questions. You can raise your hand, or else you can paste your query in the WhatsApp group.
Okay, before that, ma'am, I want to just discuss one thing
Yes, sir.
with that participant, that this part we have already started to work on this computational modeling in pharmaceutics in 2009, but that is included as a part of MPharm pharmaceutics syllabus in 2016. The topic or name of that subject is computer aided drug delivery system. So in that we have already worked from or working from 2009, and we have explored this area. We have published near about 13-14 papers in the same area. So we are now have come up with some how to actually practically apply this computational modeling approach in formulation development. So if anyone is having any kind of doubt, you can discuss.
Yes, of course. That is depicted from your presentation that lot of work has been done by you and your team in this area of QSPR and its application as far as the formulation design is concerned. So I think there must be many participants from many pharmacy colleges, those who are working in formulation development. So those participants can raise questions, or if you have any doubt, you can discuss it with our resource person. I think I'll start with one of the query. While you were discussing about the validation of the model, and I think you talked about the percent drug release, where you had shown the values somewhere around 69 and 61 regarding the predicted value and the experimental value.
Yes.
Yeah, so I would like to know, generally, say when we are validating a model, so whatever it is, may it be percent release or any other property that you are evaluating, how much percent deviation generally would you consider good as far as the predicted value and experimental value is considered?
Okay, that totally
Are there any such rules, or that's all up to the property that you are studying? Or
that
anything else?
totally depends upon that how much accuracy we have kept during that preparing that formulation, because while evaluating and replicate that formulation also, that whatever standard deviation we are getting, that also gives some idea about how much deviation you will get between predicted and experimental value. If that release, for say example, it is 60% plus minus 20%, no doubt that will give a good high difference between predicted and experimental value. So generally speaking, if you are having a good formulation with proper method for evaluation, then you will get less standard deviation. And if that standard deviation is at minimum, you can consider up to 5% or 10% deviation from actual and predicted value.
Yeah, right. Thank you so much, sir.
Yes.
There is one question in our WhatsApp group from
Yes.
one of the participant, and they
Yes.
have pasted it. I don't know whether it's a question or they have made a comment, but I will read it out. They have written validation is dependent on productivity of compound. So
Yes, I'm also
I
not getting. Is it question
yeah
or
yeah, even I
okay?
did not get whether it was a statement or you wanted to share a
Mm-hmm.
statement or whether the question has been asked. If the participant can make it clear, it would be better. That what do you want to know? Participants, any questions from your side? You can raise your hand. Yeah, I think it's a
Okay.
bit different topic.
Yes. Yes.
Generally, many people do not work in this area,
Yes.
but
Yes.
I think it's a great success as far as the artificial intelligence and its application in the formulation development is concerned. So
Yes.
I think this will give a stimulation to many those who are present over here as a participant to work in this area.
Yes. Yes.
Yeah, there is one question from one of the participant.
Hmm.
Please enlighten how it would be helpful for crude extract.
Crude extract.
Yeah,
So you can select, suppose for extraction you want to select the proper method, in that want to select solvent for maximum yield. Again, if you want to select processing time, all these parameters you can select based upon that. What are the first you need to select which are the significant parameters, or by applying that pat, and after that if you are finding with that key, suppose solvent is having that suitable impact on extraction properties and yield of that your extract, then you can select number of solvent and apply that computational modeling approach with use of that solvent, and just get up finish up with which solvent is best for your this one extraction of that active.
yeah. I
Okay, is
think
it? Hmm.
crude extract I think can be considered as one of the API, and then you
Yes,
can
yes,
yes.
yes.
Yeah, and then you can study the various properties with different types of excipients depending on what kind of formulation you desire out of that crude extract.
Hmm. Yes.
Am I right, sir?
Yes, sir. Yes, ma'am. You can select that crude as one of the drug, and you can just find out which parameters are having significant impact on that whatever target means response you are expecting, either yield or quality or anything, means amount or quality. So based upon that, you can select that parameter.
Absolutely, sir.
Yes.
So I think I see no more questions from participants.
Yes. Yes.
So on behalf of Bharati Vidyapeeth College of Pharmacy, Kolhapur, I thank you very much for your wonderful session, for sharing all your work with all of us. And this probably will help us to think more in the direction of quantitative structure property relationship and its application further in formulation design process.
Yes, ma'am. Thank you.
Yeah.
Thank you so much
Yeah.
for invitation and your time. Thank you, ma'am.
Yeah. Thank you so much, sir.
Yes. Can I leave now?
Yes, sir.
Okay. Thank you.